Hi everyone, so here we're going to talk about rates of reaction, so pretty much what helps reactions occur faster. This is what we call kinetics. So you'll need your notes for this. So there are basic factors that affect rates of reaction. We call them effective collisions. So that term effective collisions, highlight it, circle it, do whatever you need to do, but those are the magic words in order to figure out how well a reaction occurs. So effective collisions pretty much involve orientation and energy. So imagine that you're hitting a hockey puck and you're just barely tapping it. Well, it's not going to go anywhere. Okay, so what if you put a whole big swing in it and you miss? Again, that puck is not going to go anywhere. So again, you need to have the correct orientation and the energy. So the orientation is correct contact, and the energy is the amount of, again, that amount of force that's being put into it. So if you look in the first column, here, it has a lot of energy that's occurring. So we're actually putting together A and B and want to form a product at the end. So when we put the A and B together here, there's a lot of energy. That energy is being represented by those little star-like parts to the middle right here. But there's not correct orientation. So pretty much we want an A to combine with a B on either case. But if you only have one A attached to one B, well, these guys won't ever see each other. So that's not correct orientation. No products will form. Let's take a look at the middle one. Okay, so if we arrange them, so an A is going to be in a contact with B, that's good, but it barely taps together. Well, that's still not going to be enough energy, so no products will form. So the third column shows you, hey, it's in the proper orientation, that's good, and if we put them together and put enough energy into it, look, they will form the products that we want. So whenever we have effective collisions, it means that we need to have correct orientation and enough energy. So there are other things that affect how well effective collisions will occur. So the diagram on the right shows you that, mixing. We have correct temperature, concentration, a presence of a catalyst, and pressure. So for mixing, we want to make sure that those particles are moving all around. The more that they're moving, the more energy that there is, and allows for more effective collisions. So the more likelihood that you'll have proper orientation, as well as enough energy. Temperature. Temperature is kinetic energy. So when you increase the average kinetic energy, we are increasing how fast these particles are moving, and we allow for more effective collisions because we have enough energy between particles when they hit one another, and because since all the particles are moving around so much, there's more chances to have correct orientation for these as well. So the higher the temperature, the higher the kinetic energy, it allows for more effective collisions. For concentration, the more particles that you have in a given amount of solution, the more likely that you're going to have these particles mix around with one another, and since they're mixing around, you'll end up having more energy and better orientation for these as well. So again, more effective collisions. Catalysts, this is the big one. So back in bio and back in science before, we told you that catalysts speed up chemical reactions. Really, the big thing that catalysts do are lower the activation energy. So we've seen that term activation energy before, and we saw that in a potential energy diagram, which is shown right here on the right. And I do want you to copy this down as well. So this is a basic, let's see, we have the curve going up and then all the way back down, so that's an exothermic reaction. What a catalyst does, it actually comes in and lowers that energy needed, so that activation energy is much, much smaller. So when we look at the reactants, let's see, so this is the line for the reactants, this is the line for the products, this is the line for the activated complex. That catalyst lowers that activated complex, so there's less distance between the reactants and that activated complex. So really it takes less energy in order for this reaction to occur. So it doesn't necessarily, it speeds up a chemical reaction, but here in chemistry we know more. We know that it actually lowers the activation energy. We also know that catalyst doesn't get used up. It's shown at the end of the reaction. And during the reaction, we might see it over an arrow. So for example, if we see PT, platinum's used as a common catalyst, an inorganic catalyst, it's shown above the arrow in a reaction. So if you have the reactants here and the products here in the chemical reaction, you see the PT above it. And again, that shows that there's a catalyst in this reaction. That catalyst does not get used up. Right? Pressure. Pressure is only involving gases. So highlight it, circle it, whatever you need to do, but just make sure they emphasize the fact that it's just gases. So when you increase the pressure, we know due to Boyle's law, the volume actually goes smaller. So when we make the volume a lot less, there's more pressure, there's more particles hitting the outer edges of a container. And since there's more movement involved with that as well, there's more chances for proper orientation and proper energy, which allows for more effective collisions. All right? So to summarize, know what happens as a result of each of the reactions. Know what effective collisions actually means. Know what reduces activation energy, and of course that's a catalyst. And for all those factors that we had talked about, understand and be able to figure out, or even reason to yourself, why would increasing temperature be able to increase the effective collisions? Why would increasing pressure be able to help out on gases? All of those little things. All right, darlings? So make sure you have notes on all of those. Have a good day.